problem here. Usually when you're doing these, just try to come up with a picture first. So it says a rectangular page, so I'm going to start with a rectangle here. You can draw a rectangle, I promise. Okay.
That's a really good rectangle.
Just wait. Okay, so it says a rectangular page will contain 54 square inches of print. Okay, now if we keep reading this, the margins at the top and bottom are 1.5 inches, and the margins on each side are 1 inch. So is the printed area in the margins? No, it's just the inside piece. So we kind of have a rectangle within a rectangle here. Okay, so the printed area, it says is 54. So that would be this area here, right? Does that make sense? So I'm going to make this my x and my y. So what can I do with this 54 to write a secondary equation? X times y is equal to 54. Is everyone okay with that, or any questions on that? Now, what do I know about the length from here to here? 1.5. And the length from here to here is 1.5. So what would be this entire length here? Close. Y plus 3. Okay, because you're taking this y here plus 1.5 up here plus 1.5 down here. So y plus 3 total. Okay, what's the length from here to here? 1, and the other side is? 1. So that length of this entire side is going to be x plus 2. So any questions on my beautiful picture? Whatever, it's nice. Okay, so now it says, what should the dimensions of the page be to minimize the amount of paper used? So what's my primary equation? So I'm trying to minimize. And what am I trying to minimize? The amount of paper used, which would be what? The area, right? So my primary equation is an area. And I want the area of the entire page, so how do I find the area of that entire page? Okay, so x plus 2 times y plus 3. And then what do I do in order to get this so that it doesn't have more than one variable? I replace one of them, right? So usually I replace the y, but it really doesn't matter which one you replace here. Why? Usually things are in terms of x. Okay, so what's this y going to equal up here? 54 over x. So that's just going to go in this spot here. So any questions on that? And that's like from here on out, it's the same as the other questions were essentially, okay? Yeah, it's a setup that will get you caught. So now I have my area in terms of x. If I multiply x times 54 over x, what do I get? 54, the x's cancel. And x times 3 will give me 3x. 2 times 54 over x gives me 108 over x. And the last piece, 6. And then I'm just going to rewrite it so it's easy to take the derivative. So my 3x I'll write first. How can I rewrite this 108? There we go. And then plus, what in the back? 60. Which is going to be 0, so if you mess that up, no big deal, right? Okay, now if I'm trying to minimize this, how can I prove it's a minimum? So there's 2 ways to do it. So I first have to do the derivative. So derivative is 3
minus 108x to the negative second.
108x to the negative second.
Plus 0.
Plus 0 if you want it, sure. So this would be 3 minus 108 over x squared, right? And I like the second derivative test a lot of times because it's a lot quicker. but you can definitely do the number line also. So if I'm going to use the second derivative test, I'm going to need my second derivative, so I'm just going to take it right now. So the derivative of 3 is? 0. And what's the derivative of this piece here? 216x to the negative third, which is the same as 216 over x cubed, right? Now what do I have to do next? Find when what's undefined?
Alright, let's slow down.
Of what function? What function are we studying? First derivative. We want our critical numbers. So we're taking our first derivative, and I'm setting it equal to 0. So if I set this equal to 0, can't I just add the 108 over x squared over? So this turns into 3 equals 108 over x squared. And then cross multiply. So I have 3x squared, guys, equals 108. So x squared is, so x has to be 6. And negative 6 doesn't make sense here, right? That's part of your feasible domain, which we didn't write out, but we should be able to kind of do that mentally. Okay, so our x is 6. Then what do I do with that in the second derivative test? Plug it in. So if I plug that into the second derivative, is it going to be positive or negative? It's going to be greater than 0, right? If it's positive, that means it's concave up. If it's concave up, max or min? Min. So I know there's a min when x equals 6. And if x equals 6, what's my y equal? If my x is 6, wouldn't my y be 54 over 6?
Yep.
So my y is
9.
9. Now that's not what the question's asking, so we got to go back and read the question here. So it says, what should the dimensions of the page be? So I know my x and my y. Is that my page? No. What's the whole length of this side going to be? X plus 2, so that's going to be 8. And then the y plus 3 is going to give me 12. So it's going to end up being 8 inches by 12 inches. 8 inches, yep, just by 12 inches, because it's not asking for the area here, it's asking for the dimensions. Yes, yep, you could go 8 by 12 inches, that would be fine. Okay, the same thing. So any questions on that? Yeah, go ahead.
No, you're going to take this quiz.
So no other questions? So there's your entire assignment there. You should be able to pick up where you left off now.